Okay, so the goal of this and really the blog post that this is based off of, um, I kind of think of it as, trying to reflect on why we like reach for the open source tool or the third party tool in the first place to achieve mocking. And that's really, that's true of any language, I guess. Um, but in Go, I've had experience with several, and then I've kind of over time gotten away from them. So that's really my overall perspective. And then the goal is to examine how we can do it without frameworks. And really, that's also an exercise in understanding how the frameworks themselves do it. If you understand what the capabilities of the language are, then you'll understand, even if it's more complicated, like code generation, you understand how these libraries do it. And then, ideally reflect and discuss best practices. That's probably what I'm most excited about to hear from you guys. Okay, so what is a mock? I know maybe some of you are feeling like that meme right now. I think, mock and stub and spy and fake, I think they're very overloaded terms for a lot of people. So I'm going to go with just the broadest definition of a mock. It's when we substitute code for a unit test. Why do we do that? Typically, it's to keep unit tests reliable and self-contained, right? Database connections, HTTP calls, you don't really want to exercise those fully in your unit tests. So, leaving out even the motivation, this is the definition I'm going to go with. If you feel, that the conversation, you could add value to it by distinguishing between any of these three, let me know. But I always like when I read these, I hear some definitions. It always just kind of blurs together in my mind anyway. I don't really split hairs, but if there's a good reason to distinguish, just let me know. I think that'd be a cool opinion to hear. Okay, so a few of you mentioned table-driven testing. And I think it was mentioned that it kind of gets ugly, and I definitely agree with that at scale. But nonetheless, I tend to do it a lot. So this is my basic test scaffold where I do like, this is the basic framework for a table-driven test, right? We have one actual test function per function or method under test in your source code. And then inside there, you make a slice where you define the inputs and outputs. Those are all your subtests. And then at the bottom, you'll just range over that and actually run through each one to make sure everything's correct. I think it's a good way to test probably in any language if you want to test multiple scenarios. I think in Go, it fits as well because you have multiple return parameters a lot of times with function local error handling. You're passing back that error a lot of times in functions. So most functions that you want to test, they have at least the happy path with no error, and then they have at least one error case, right? So I don't like to write a bunch of different unit tests that all test the same function or method. I like to have it in one place and then kind of use this declarative style here for the specific subtests. So one thing that you may not even have noticed in this, I try to test from a test package. And the reason for this is so that you only test through public members, right? And this is not novel to Go. This is something that you might do in Java or any other language as well. You only test through public members. In Go, every directory that has source code needs to be, like each file needs to be in the same package with one exception, and that's the underscore test package. So that's the way to do it if you want to enforce that you're only testing through public members. What does this get you? It simulates the way that clients are going to use this library, right? If you find this difficult, it's actually a pretty good litmus test for how well your library is written in the first place. That's kind of why I like it. If you're finding it difficult to reach code, that's private. That says something about the way things are designed, probably, right? If it's impossible to reach code from public members, that's actually the definition of dead code, which maybe is non-obvious, but you think about it and you're like, okay, yeah, actually, if I can't reach it from the public API, then there's no one can ever reach it. So if you're finding that difficult, or you're finding yourself setting up a lot of things that you don't really care about just to get to one particular line of code, I think someone mentioned refactoring. That's where, I would do probably one of two things, right? I would either kind of grow the public surface, the public API of my package, add more things, which is to say, maybe you break up one function that does everything into a couple that clients can call. That's one refactoring method. Another one is, try to break out more packages underneath. And then you kind of outsource the responsibility of testing that logic that was a very deep in the private code. You kind of push that off to a different package, and you reduce the depth from the public API down to the logic that you're after. So that's, those are the two things that come to mind when I'm doing this and I find it difficult. This is an underrated feature of testing in Go. And it's really great for table tests. T.run. So every subtest at least has a name, which is a string, and that describes, I didn't give a good example here, but that describes what you're testing, right? So that's a really good way to structure your tests, because what ends up happening in the output, and we'll see this in the demos, you get a nice hierarchical output where you see the subtests for each parent test. Another thing it enables is if you want to throw a t.parallel inside here. So if you throw a t.parallel up here, you'll be running this entire test alongside the other parallel tests, right? If you throw it in here, you can even run the individual subtests in parallel. Be careful because concurrency rules apply, but it enables you to do that. It's really just like another test that you would write out here. And also, it's the same, it's a pointer to the testing.t structure. So if one of these fails, it'll fail the parent too. So it kind of propagates up, and you're not left hunting for which subtest. It'll fail the outer test, and then it'll tell you which subtest caused the failure. So very underrated feature. I pretty much always do this. Know the players, know the game. I just want to hear from anyone. Have you used any of these third-party packages? And if you could kind of reflect on why you chose them or what your opinions are of them. I'll just go first, I guess. I've used GoMock and MockGen pretty heavily at my current job. The reason I use it, I don't love them, but I use it just to remain consistent with the way that other engineers do things. And what we specifically use this for is for Grpc. So when you are really writing any code that connects to a Grpc service, you're working through interfaces already. It's just the way that, the compiled protobuf gets structured. You'll have a client and a server interface. So we run code generation on those interfaces, and then there's a nice, almost like behavioral API from GoMock that allows you to mock out the responses of those calls. I know a couple of people had mentioned Grpc. This is what my company does a lot. The concepts we're going to cover, they apply as well to Grpc. You don't need to do this MockGen or GoMock, but that's like a pretty popular use for it. If you look at the Hello World example for Grpc on GitHub, they use this for the unit tests. And this is also, notice this is supported by Golang. So this is kind of the heavy hitter in this list. GoMock and then MockGen is just a package in that. I've used GoSQLMock as well. And I think I used that when I was very new to Go, and I didn't really have the confidence to structure code well myself. and I just wanted a quick way to unit test some SQL code. So yeah, that's my experience. Has anyone used any of these and have any commentary on any of them?
Yeah, I've used Testify a whole lot. A couple libraries that I like in there. The Assertion Library, I just think makes the assertions a lot clearer than the just, out of the box Go way of doing things. So that's nice, and it's just like very simple package to import. And then the suites are nice when you have like a big like object that you're trying to like mock a lot of like things that are inside of it, and so you can like get it to set up before every test, and set up all your mocks and everything. So that's nice. Not always necessary, but sometimes very useful. And then the mockery is just nice to generate mocks for like any of your interfaces, and just be able to declare exactly what you want them to return.
I've used GoMock and GoSQL. GoMock at my last job, GoSQL currently. And the thing that I like about both of those is it's a more direct way of being able to check inputs to your queries. So, right, you have a database object that does a whole bunch of stuff. You get to intercept it at the SQL layer and see what the query is in like a very natural form. And that's been very useful for us, especially because like when we're doing unit tests on the DAO, like it's really easy to just like say like, okay, is this the query that I'm looking for? Yes or no, versus like just making sure it gets called and then doing nothing, because like the meat of the function is building that query for you.
Yeah, so you like the way that you can like capture inputs and then add logic on that.
Yeah, and being able to really take a look at the inputs that are being passed into SQL and into the function under mock for GoMock, just to make sure that you're calling the right thing as part of the test.
Yeah. The analogous thing in the examples we're going to look at is like, instead of having some library do that for you, what you'll do is actually create a struct that implements some interface, and you'll put the fields in the struct that you want it to return. And then in each subtest, you can define different fields. And so that's your way of saying, in this case, return this, in this case, return that, which, probably will make perfect sense if it doesn't already. But yeah, cool. I know Testify is really popular. I want to get back to what you said about the Assertion Library. I forget who that was. I think it was somebody's. Oh yeah, Grant. Grant said you like the assertions, the style. I like how the normal vanilla Go way, I like how that actually reflects the way that you do error handling. So when you assert something in a test, you're usually asserting that something is true, right? You're asserting some value, or you're asserting that something exists, is not null, whatever. When you do error handling in Go source code, instead of saying if error equal to nil, proceed, right? You say if error not equal to nil, meaning something went wrong, preempt, right? Like fail the function. So I kind of like in a unit test then, if you think of it differently than an assertion, you think of it the way that you actually error handled in the code. It's like, okay, instead of asserting something's true, I assert that something didn't break. And if it did break, then I fail. So I kind of like the way that it rhymes with the way that you write source code, just to provide you a different perspective. That's usually why I don't reach for assert as an instinct, but I will say Testify has a lot of useful utilities. Like when you're comparing slices, right? You don't care about the order. Like, are you gonna write a sort yourself just for the test? Are you gonna, turn it into a map or jump through some hoops? No, you can just use Testify has some, useful utility for you. So that's just, me giving you a different perspective. But I definitely, if other people are using assert, I might just use it too. Okay, so to jump into the examples here, I don't know if you guys experience this, but like I hate when blog posts or technical posts, they give really long, convoluted examples just to explain a simple technology. So everything when I write, I try to write as I'm thinking about problems, like when I'm coding. So that's what these bullet points are. Like, I need to mock a function, right? That's a situation that comes up when I'm coding. I don't care what the purpose is. I don't care if it's a database or whatever. Like, when I'm indexing things in my brain, that's how I think. It's like, this is the situation I'm in. This is how I should act. So I'm going to try to, keep the examples very short and complete. They're all runnable. That's what we'll see in the demos, but that's basically how I broke up this blog post and how I want to proceed here. But yeah, this is what we're going to cover. So this situation, I need to mock a function, just a package level function, method on a type. What about the situation where I have an interface? It's just I only care about a few of the methods. And then HTTP call, which I know a couple people pointed out in the beginning they wanted to cover. So that'll be the last example that hopefully gives you some insight. Okay, I want to hear from you guys, or maybe just like thumbs up, thumbs down. Is this visible to you guys? Is this okay if I play a video with the font this size?
That's good.
Okay, because I can switch over to live if this is hard to see. So if at any point you can't see this, just let me know. Okay. All right. So the first example is, I apologize. The first example is just a simple function under test called OpenDB. What does it do? It calls SQL.open. Okay, so SQL.open is the troublemaker. We don't want to test that. We want to mock that out. One strategy we can use is we look at the function signature itself, and then we create a higher order function out of OpenDB, and we pass in that function to it. So when I do this, I like to make a type that matches the signature of the function. So right now I'm just calling SQL opener type. I'm defining it as the same signature as the actual SQL.open. And then I'm just going to pass in something of that type to this method here. And then use that instead of, calling SQL.open directly. So really simple way to inject your own function. Then we're going to look at the test for that. Yeah, table test construction here. And I know a few of you commented on, the table tests get kind of unruly. If this is hard for you to read, maybe you don't prefer that style. But for me, this is, usually how I write them. There's two cases. There's one for, a normal connection, and then there's one that I'll return an error. So that's basically it, right? Pretty straightforward. First strategy is using a higher order function. So what was good about that and what was not so good? The good part about that is the injection that you're making, what you're actually mocking, it's proximal to the function under test. So it's right there in the function parameters, right? It's very clear. You don't need to go look somewhere else. There's no side effect. It's a nice stateless solution. It goes into the function and it gets invoked. What's not so good, this can get pretty ugly. If we hadn't made that type SQL opener that matched the signature, we would have had to copy, func string to whatever the return values were. That would have had to live inside the signature of our method under test. And that can get pretty overwhelming to look at. So that's why I do the custom type itself. And then the last point I would think is, non-obvious is like the SQL example, maybe you were trying to encapsulate all the SQL stuff in one package in your project. If you were to switch that to like MongoDB or DynamoDB or something, you might want, the rest of your project to be resistant to that change. But what happens when you when you make it a higher order function like that, is the callers of the package now need to import SQL themselves, right? Because they need to call your function with SQL.open, the reference to the function that's actually going to be used. So you're kind of growing your dependency graph when you do this. And you might very subtly be breaking a nice encapsulation of like one responsibility. So that's, is it materially bad? I don't know, but it might be just something to consider. Okay, the next strategy here, same function, OpenDB. Instead of passing it into the function, we can make a variable, a package level variable, and just point that to the real function, right? And then in the code, we're using that variable instead of something that we passed in. So I call this monkey patching. I mean, that's a little bit of an overloaded term as well, but package level variable, it's stateful to the package. And then in our test, instead of passing it in, we're going to do something here where we actually assign the variable in the source code package to whatever we have in our subtest. Right, so now when the source code invokes the SQL open, it's going to be doing our definition of the function. So this is a little bit smelly to some people when they first see it. And I accept that. I accept that this is, maybe weird to people because it's stateful to a package. But one good thing is you don't need to modify the function signature. You don't need to grow that dependency graph into other packages. It's still isolated to its own package. One subtle thing that kind of relates back to the capitalization, the public-private, you need to make that member public when you're testing from an underscore test package, which is weird to think, right? You don't really want clients of your package to be changing that or have the ability to change that. But when you test from, the client's perspective, then you need to add that. You need to add that capital letter. So that's a little bit weird. And this is not good for parallel tests. If you ran the subtests in parallel, they'd all be competing to set their definition of what the variable is. It's shared state, right? So that's another sort of hazard with using this way. Okay, so moving on, a method on a type. This one should be pretty familiar. So here's an example of a function that reads from an os.file. And an os.file is a concrete type. And we use two methods on that, read and close. If we go to the definition of os.file, we see that it's just a struct. Okay, so it's a concrete type. What we can do instead is use an interface type, right? We don't want to actually open and read the file and call close on it. We want to supply our own definition. And there happens to be some really useful interfaces in the IO package in the standard library, one of them being read closer, that does exactly what we need. So a read closer is an interface that embeds two other interfaces. One of them is reader, one of them is closer. So that means that a read closer needs to satisfy those two interfaces as well. And then read, that's probably pretty familiar to most of you guys. And close is just something that closes. So when we sign our function under test with a read closer, we're saying it's something that can do both of these things. And we know that an os.file struct can do those because that was our original implementation. But now with read closer, we can supply our own definition of read and close. So the magic here is in this top part. There's a mock read closer struct, and then there's two fields inside there that are basically like you declaring what you want to return, right? And we're basically only going to mock out the read function here, but just note that the mock read closer it satisfies IO read closer because it implements read and close, right? And then our goal is just return those fields here and allow the subtest to set the fields and instantiate this struct. So this is now something that satisfies the interface, can be passed in to the function under test, and we're controlling what gets returned. So we're mocking, right? This is the subtest. There's two test cases. One of them where we actually write some bytes, or sorry, read some bytes from our mock implementation. And then another one where we get an error from the read itself. So pretty straightforward, but that's a very powerful construction where you kind of use the fields in the mock struct and let your subtests set those fields, and that becomes the mock values. Yep, and we run that and see that it works. One thing to just call out here, there's kind of a paradigm in Go that's pretty subtle but really powerful. It's that you should accept interfaces and return structs or return concrete types. When you call os.open for a file, that returns a struct. It returns that os.file struct. But what we want to do is, instead of passing that around, we want to accept an interface that does the things that we need. In Go, since you don't need to explicitly implement any interfaces, it's implicitly checked at compile time. You don't need to like sign your function's return values as interfaces. You can just return the concrete implementation and then let the people who use it treat that as an interface type. And we used IO read closer, but don't be afraid to define your own interface. That's where you would define your own if that didn't exist. You would say, I need it to be able to do this and this, and you would define that. Okay, large interface. And I know I'm close to 9:45 here, so Lauren, feel free to stop me at any moment. We've got two more of these. This example is with DynamoDB, and I just made a function that calls some method on a DynamoDB client, and it's basically making a database call. Okay. For the sake of the example, one thing that this AWS SDK provides is this interface type. It's iFace. I don't think this library is very idiomatic, but it's good for this example because if we go to definition on that interface, we see this is literally the entire method set for everything you can do with DynamoDB. Okay, and then if you pass this around, yeah, sure, the one thing that you care about for this function is in there, but how are you going to satisfy this interface, right? You don't want to have to mock all those things just to get after get item, right? So that's the situation, that's the point of this example. So if we look at the test, the magic happens on line 14, where we make a struct, a mock struct, same way we define the fields for what we want it to return, same as the last example, but we're going to embed that big, huge interface on line 14. And what that does is, similar to read closer, it says, okay, I'm going to satisfy this interface implicitly. And then down here, we define get item to do what we want, right? We only need to override, it's method overriding, right? We only need to override the one thing that we care about for our tests. So that's how you can get around that huge interface problem. You just embed the huge interface in a mock implementation. And then from there, you can just override the specific things that you want. I'm gonna cut this one short just so we get to the last one, because I know there's some interest in this one. Embedding is weird, by the way. I'll skip over this example, but it's basically kind of like a hole in the type system, because your mock struct there, it passed the compile time check, but you've really only implemented one of those methods. If you were to call any of those other methods, it would panic. That's what this playground shows. So just be careful with that. All right, and this is the last one, HTTP calls. So outgoing HTTP calls. My code calls another service. A pretty simple setup here. I have a response struct with JSON tags. So this make HTTP call function will issue a GET request, check the status code, read the body, and then unmarshal, deserialize and return the concrete type of response. So how do we actually make this? How do we inject like a different behavior? The way to do this is to focus on the URL and specifically like the base of the URL. So you should, when you're making HTTP calls, always parameterize the URL string, at least the base of it. So here I'm going to replace this with just URL and then concatenate on the resource or the end of the URL. So when I do this, now this is testable. And the way that it gets tested is through this net HTTP test package in the standard library. So you see in our table test definition, every subtest has a server and it's a test server. So what a test server is it's just like a normal server, except it's running on your local loopback interface. So it's self-contained, like there's no external network aspect to it. But the beauty of this is that you're gonna run as much code as you would normally if you were making the real call, but it's still self-contained and reliable. So any of the other mocking techniques that we talked about, you could use those. You could mock out, for example, an HTTP client, or you could substitute the function itself, right? You could use those, but this is a little bit better because it's more thorough, right? It's actually going to make your code think that it's making an HTTP call and serving up a response that you define in your test, but it's still going to be self-contained. So that's what you're seeing here, these server definitions. Here, I'm actually going to return bytes, right? I expect my code to unmarshal those and then return me this response here. So it's a pretty cool way to, think about the mock itself as a server that's serving up the content. Yeah, and here I can return a bad status code and then I expect an error. So that's it. And this is the most important part. Send in the server, the test server URL, because that's what's going to tell your code where to connect. And by making the right call there, you're going to stay within the local network. So that's how you parameterize that. That is basically it. One point to that, in that example, it was one server implementation per subtest. You can treat it just like a normal server with multiple routes. You can check, anything in there. You can use Gorilla Mux if you wanted to, really, because it's the same as a normal server. So you can go crazy with that. I just think it's easy to define a server per subtest. So that is the extent of what I had to cover. And these are the notes that I jotted down. I'm not sure, Lauren, if anyone has a hard stop at 9:45, but I can just keep going here and then anyone chime in on these topics.
Yeah, sounds good. I think we just need to wrap up a couple minutes before 10 o'clock, but if you want to either run through these discussion points or if people want to chime in, if they had any particular questions, we can open that up.
Definitely, yeah. So the first three are mine. Those are pretty self-explanatory, so I don't need to dive into those. But hopefully, your takeaway from this is that there's a blog post out there that you can refer to that kind of indexes situations with small complete code examples, and maybe that gives you a little bit of confidence to try mocking things out yourself before you reach for a third-party library. If those libraries make your life easy and you understand them really well, then go for it. But I think it's always good to understand how the language provides these capabilities itself. So moving on to this bullet point, the gRPC, let me take gRPC first. So there is something similar to httptest, that last example, called buffcon, and this is inside gRPC. And this is basically the same concept. This creates an in-memory buffer for client-server communication between two gRPC endpoints. So if you're testing an outgoing gRPC call, this is what to use. So I can throw this in the chat real quick, but this is the analogous solution to net HTTP test. Okay, It creates an in-memory buffer, and that way you're still self-contained, but your code thinks it's actually issuing the gRPC call. So a nice little underrated subpackage in gRPC there that'll get you maybe more comprehensive testing. gRPC, you already get a lot of type safety, right? But maybe the size of the payload's too big or something. You wouldn't catch that normally if you just substituted the code. So it's a nice way to just be more thorough. Chet, I believe you mentioned authentication. Could you elaborate a little bit on that?
Yeah, so if you wanted to mock the usage of like an OAuth 2 API call stack,
yeah,
would you do that with a similar technique with the full test server, or would you just use one of your other testing methods?
Yeah, you can use, if it's a normal HTTP call, you can use that net HTTP test. I have done that before. If you're talking about like, I hit a gateway service or something to get a bearer token, yeah, I'll mock out the bearer token coming back with HTTP test. You can do it the exact same way because that's basically what it is at the end of the day. So yeah, I think that's a good solution for that. Or of course, you can use any of the other methods. But that should cover it for normal HTTP. Okay, AWS Lambda. So Lambdas are really interesting. The way I test Lambdas mostly is I just write unit tests, right? A Lambda is just a function, right? If you think of it as just like a code function, yeah, it has a main, but you can test main, right? If you write a unit test for main, that's kind of like an integration test that you might do on an HTTP service, for example, where you're, hitting and getting a response and asserting it, right? So if you're just lazy or you don't really want to set up anything like that, just write a unit test for the entire code, right? After all, that's the promise of serverless, right? It's like, just give me code, that's my product. So if that's the case, then unit tests should cover that. That should be extensive for your entire test suite. If you do want to actually like build an integration test suite that invokes a Lambda, I've had success. I've done that with SAM CLI and like Dockerizing SAM CLI and having something actually invoke with like the normal Lambda payload and then get a response. So you can do that as well, but really, I think it's pretty thorough usually just to write a unit test for the main function of your Lambda. George or Anthram, does that kind of cover what you were after, or any other questions about that?
No, that makes sense. I think that's not too far off from where we were going, but it's always nice to hear that I'm not totally going off left field. That's very helpful. Thank you.
Yeah.
Yes, same here.
Yeah, it's not as straightforward as like a black box where you can just hit a server, get a response. But again, if we're trusting that it is really code as infrastructure, then unit tests should cover it. Table tests get messy. Tyler, if you're still on, do you think those examples were messy? Maybe he dropped, but yeah, I mean, they can get messy. Like take those examples and add 5, 6, 7 more subtests. That can be pretty huge. So you can always break that out into multiple functions. I never get up in arms about that if people write it in multiple functions because it's too big. Generative testing and fuzzing, that's one thing also I wanted to call out. There's a proposal now. So in a unit test, you have testing.t objects. And testing.b for benchmarking. I think there's a proposal for testing.f, like fuzzing. It's pretty cool. I didn't read the whole thing, but this is out there now. Someone, yeah, first class fuzzing. Yeah, a testing.f. So I'll send this in the chat too. I think that'd be cool. I think that'd be cool if that could be included in your test suite. Whoever mentioned this, Damien, anything else you wanted to talk about with fuzzing?
Yeah, that's great. I'll definitely take a read.
with that. Through that, yeah, the thing I've always wondered about generative testing in terms of mocking is just like what situations outside of like data validation or just taking an arbitrary like slice and making sure that that's not going to cause an mix overflow or some other problem. Seeing how it's used in practice, I think would be really interesting. So that's really cool to know that it's being considered as a first class testing thing. That's cool.
Yeah. Yeah, I'm excited to see if it makes its way in. I don't have a lot of experience with this stuff, but yeah, it seems really, really cool, useful area. And then Sundar, could you explain a little more about the service mesh concept? Do you mean like more like integration level testing when you're using a service mesh, or could you give a little more context there? Maybe maybe they dropped or. Okay. In general, I think a service mesh should be additive, and you should not really be considering it much when you're developing locally or testing. That's I don't know if that's helpful, but that's how I see it at least. But yeah, that's pretty much all I had, Lauren.